Welcome back, everyone. Today we're going to discuss about writing systems of linear equations. So for this workshop, we're going to tackle 3 objectives, and let us begin. Objective number 1, I can write systems of 2 linear equations given a graph. Example number 1, which pair of equations corresponds to the 2 lines in the graph? Since this is a workshop, I just want you to make sure that you're utilizing the technology. And in this case, we are plugging and matching which of the equations match the graph. So let's begin. So I plugged in choice A and it is not the right graph. So now I went ahead and plugged in choice B and it looked to me like it's the right graph. I'll just have to look into some key features like this line right here has a y-intercept of 6, which this has. This one has a y-intercept of 2, which this has. And it is at 1.3, 4.5, like about halfway, and it looks like it is the right graph. So even if you've already found your answer B, I still want you to look and plug in C and D just to make sure that you are checking all the answers and really looking for what's wrong with them so that you can finalize your answer and really say that the right answer is B. So example number 2, which pair of equations corresponds to the 2 lines in the graph? So once again, plug and match. So I had started with choice A and I think we found the answer. I think this is the answer, but just to finalize this, I'm looking for some key features. So that's the y-intercept of the first line. This is the x-intercept of the second line. And I wanted just to emphasize something here, guys. If the slopes are the same, but the y-intercepts are different, you're going to have parallel lines. So even if you don't graph this, you can tell they have the same slope. So that means that the lines are parallel. And for the first line, this shows the y-intercept, which is at 2. And for the second line, this is your y-intercept, which is a -6 right there. So our answer is letter A. Objective number 2, I can write systems of 2 linear equations from a table. So let's look at this problem. Graph the data and then find the slope and y-intercept from the graph and then write the equation for the graph and the slope-intercept form. Okay, let's look at this. So you have all these values in a table. So you open up your table. So click on the plus sign and then enter all of them. Upon entering all the points, this is how it looks like. We are now going to get the slope. So the slope is rise over run, or you can use the formula y2 minus y1 all over x2 minus x1. I am going to do both. So let's do the rise over run, and I just want to pick these 2 points. It can be any. Also, when you do this, you make sure that the increment of numbers is by 1. Okay, so this is already by 1 because I see a 25 then a 30, which means that these are all by 1. So let us begin. So from this point all the way to this point, my rise is 1, 2, 3, 4. So that is a positive rise because I am moving up. So I'm going to put here my rise is positive 4. And my run is positive 2. So once again, here at the bottom, you can see that the increment is also 1. You wanted to make sure you're counting it right. So all over positive 2 because you're moving to the right. Therefore, your slope is a 2. So you know that your slope is 2. So now let us use the slope formula. I'm using these 2 points. I'm labeling this as my x1. So therefore, this is my y1. This is my x2. And that is my y2. And then I substituted the value for x2. I have 16 minus y1 minus 12. And then at the bottom, I have x2, which is a 4, minus x1, which is a 2. Those minus there, guys, are part of the formula, so they're fixed. Okay, so let's solve this. 16 minus 12 is 4. 4 minus 2 is 2. 4 over 2 is a 2. So now let's look at the y-intercept, and there are actually 2 ways to do this. I could generate the equation first and then go from there, or I can just consistently do my excuse me, my rise and run. So I can have 2 down and 1 to the left, 2 down and 1 to the left. It ends up here, which I believe is 8. But we are going to confirm that by using the equation. Since I have my slope and I have several points, I'm going to use the point slope form, which is, I'm given a point and I have a slope. I know that right here it says slope intercept form, but guys, remember we're looking for the y-intercept. So I cannot use this until I have my intercept. So we're going to use point slope. Why am I using point slope? Because I have a lot of points here. I can pick one from the 4, and then I already have my slope, which is a 2. So let us begin assembling this. So by the way, this y is fixed, the x here is fixed, the m is the slope. This y1 is the y value of the point we're choosing, and then this x1 is the x value of, or the x coordinate of the point that I'm choosing. I will just be consistent and use this, so let's begin. Okay, so y is fixed, minus is fixed, 12 came from here, equals is fixed, it's part of the formula, m is your slope, parentheses, x is fixed, minus is fixed, and then x1 is the x value of the point that we chose. So after this one, that is actually already a valid equation, which I can plug in here. Okay, notice that after I plug this in, your line went through the points that you have identified on your table. Also, when we said a while ago that we think that the y-intercept was at 8, we were correct following the correct slope, which is the rise over run. So now let's go ahead and identify our y-intercept, which is at 8. Our equation now can be this, but because it says slope-intercept form, then we will have to follow the y equals mx plus b. And your m is a 2, x plus 8. These two are the same. Now, if you're going to ask me, how will I show that coming from point slope form, I'm moving into slope intercept form? Guys, that's another lecture where I have discussed changing slope intercept form to point slope form to standard form and all vice versa. So please, for this, the way to confirm if these two are the same is to open up your technology and plug in your y equals to x plus 8, and it should go on top. Okay, so turn that off and turn that on, and it is on top. Let's practice objective number 2 one more time. So again, you see a table, click on the plus, get the table, plug in the values. So I've plugged in all the values. This is how your points look like. We need to get the slope, the y-intercept, and the equation. So my slope is rise over run. I'm going to concentrate on these 2 points, making sure that my increment is counted by ones, both the y-axis and the x-axis. And so from this point going to this point, if I rise 2, so my rise is 2, and my run is 1, 2, 3, 4, 5. So 2 over 5 is my slope. So now I'm going to show you getting the slope using the formula. So once again, I'm choosing this as my point 1 and this is my point 2. So because this is my point 1, this is labeled as x1, y1. This is x2, y2, and all you need to do is to substitute. So my y2 is a 10 minus my y1, which is 4, all over x2, 20, minus x1 is 5. And your answer on this is 10 minus 4 is a 6 over 20 minus 5 is 15. Greatest common factor is 3, so 6 divided by 3 is 2. 15 divided by 3 is 5. So the answer is the slope is 2 out of 5. So once again, we're going to use the point slope form because I now have the slope and I have this point. So let's go ahead and substitute. Y minus 4 came from here, equals m, which is 2/5, parentheses, x is fixed, like the y here, it's also fixed, the minus is fixed, minus here is fixed, and then x1 is this one right here, the 5. So this is the equation that we're using to plug in on Desmos so that we can see that it is going through all the points that we have identified from the table. And then we now look at the y-intercept is a 2. So now that we have the y-intercept and the slope, we can now use the formula y equals mx plus b. So y equals, your m is 2/5, x plus 2. These two are the same. And to check, you can use Desmos. I will plug this in and it should go on top of the line that you had written. There you go. Okay, let's now move on to objective 3. I can write systems of two linear equations from a verbal description. So let us begin analyzing this. At a college bookstore, Carla purchased a math textbook and a novel that cost a total of 54. Okay, I want you to take note of those two variables. One is a textbook and one is a novel. Okay, the next thing is, not including tax. If the price of the math textbook M, okay, I want you to circle M, and I want you, well, first of all, we need to match this with the math textbook, because that's your M is for math textbook. If the price of the math textbook M is $8 more than 3 times the price of the novel is in which system of linear equations could be used to determine the price of each book? Okay, well, first of all, when you have systems of linear equations, you either have 2 or 3 or actually more. For the purposes of our discussion, we are using 2. So whenever you have something like this where it says that the total is 54 between the math and the novel, you are just going to simply write math plus novel is 54. So your first equation would simply look like this, okay? So m plus n equals 54. Your next equation, though, is going to rely on this one. You see where it says m is in math is equal sign, okay? So remember that. So m is $8 more. Whenever you have something like $8 more, $8 less, something more, something less, I always tell the kids to put it here at the back, so plus 8. And then whatever it says here is what you write in here in the front, and it says 3 times the price of the novel. So 3 times the novel. And that's it. Those are your two systems of linear equations. The perimeter of a rectangular wooden deck is 90 feet. So you know that perimeter can be represented by 2L plus 2 width or 2 of length plus width. So let's keep on going. The deck's length is 5 feet less than 4 times its width, and the width is represented by W. And so which system of linear equations can be used to determine the dimensions? So I would say 2L plus 2W equals 90. So that is the first equation. And then your second equation would come from this statement right here. L is. So once again, is an equal sign. So length is 5 less. So minus 5 because it's less. And you put it here. And then 4 times the width. So 4W. So that is it. These are your equations. Last and final example. Chase and Sarah went to the candy store. Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. Sarah bought 2 pieces of fudge and 10 pieces of bubble gum for a total of $3.60. Which system of equations could be used to determine the cost of 1 piece of fudge, F, and 1 piece of bubble gum, G? Let us work on Chase first. It says 5 pieces of fudge, so 5F, and 3 pieces of bubble gum, which is 3G, equals $5.70. So this is how Chase equation looks like, and for Sarah, this is how it looks like, because Sarah is buying 2 pieces of fudge and 10 pieces of bubble gum for $3.60. So guys, these are the equations for this problem. That is it. I hope that you learned a lot today.